Now today we are going to discuss about the numerical methods. And this is the notes is there more. Forward difference table. Forward difference table and backward difference table. So forward that we can tell nab delta, and backward we can tell that is nab. So forward difference table, difference operator, backward difference operator, nabla. Okay. And now see here. See, nabla y of n plus 1 is that is yn minus yn minus 1, and delta y2 that in this case we can tell that delta y2 is y1 minus y0, and nabla yn is yn minus yn minus 1, and nabla y2 means y1 minus y0. See, this is things. Okay. See, listen. So here they will ask in the examination and construct the one forward difference table. So they given 0, 0, 1, 1, 2, 8, 3, 27, 4, 24. So these are that x values. Okay. And these are the y value. So x0, y0, x1, then y is 1, x2, y is 8, and x is 3, y is 27, and x is 4, and y is 64. So how we can draw the construction table means the difference. This is both different. 1 minus 0 is 1, and 8 minus 1 is the 7, and 27 minus 8 is 19. 64 minus 27 is 37. So this is the things. And next this two differentiations, and this two differentiation, and this two differentiation. So final we can get. So this is the table. Okay. Now Newton's forward differentiation interpolation formula. So that Newton's forward interpolation formula and this. So in that numerical methods, you should remember the formulas. So if you remember the formulas, and it's very easy. Okay. So remember the formulas, it is very important. If you remember that formulas, and you will get it very easy for that thing. Okay. See, Newton's forward interpolation formula is f of x equal to y naught plus delta into p into delta y naught. So this is Newton's forward differentiation formulas. Next, come to Newton's backward differentiation formulas. So Newton's backward differentiation formula is this is You should remember this formula. Then in the examination, they will ask the formulas. If you are there asking the problem, if you write the formula also, you will get some marks. Suppose the question is carries the 10 marks. So answer is carries the 10 marks. So if you write the formula also, you will get 3 to 4 marks. So that formula is that very important in the examination point of view. Okay. So just the little bit change in that formula. Okay. In the backward and forward. In the forward, in the forward, this is P into P minus 1 by 2. In the backward, that P into P plus 1. And one more thing, there is the symbol delta will be there. And here the symbol will be nabla will be there. Okay. Now understood. So this is the difference between the forward and backward. Pencil which couple. The population of the town village is showing here, and they're asking to find out that estimation of in population is 1955. See now here, observe here, 1955. So it's 1955. It's nearest to 1961. Okay, no? So 1961 means it is that bottom of the table. So when you are going to from down to up, then we are using the what formula? We can use that backward differentiation formulas. Okay, suppose if they are asking what is the population in 1925, so then we are coming from up here. So this is that we are taking that forward formula. Understood? So they are asking to 1955, So it is in between of 1951 and 1961. So that's why we are taking that backward differentiation formula. So now write the backward differentiation formula, that yn equal to p into nabla yn plus p into p plus 1 by 2 factor into nabla square yn, and p into p plus 1 p plus 2 by 3 factor into nabla cube yn plus p into p plus 1 p plus 2 p plus 3 by 4 factor into nabla power of yn. So here only we are getting nabla yn, nabla square, nabla cube, and nabla power of 4. So that's why we are taking that only 4 terms. Okay, and next thing. So p value. So the important the p value, that x minus xn by h. So x value. So x, what is the x value means? Where we can find out, where we are to find out that value, that is called x. And what is the xn means? That last number we are taking the nearest to in the table, that is called that xn. So x minus xn by h. So that is 1955 minus 1961 by 10. So that we are getting minus 0.6. So always you should remember thing, using that backward, that h value is always some negative. Okay. So when you are in the forward, the h value should be positive. Okay. This is the negative and this is the positive. Understood? So this is the important thing, forward and backward. And the h, this all the values. So this is delta yn, and this is delta square, and this is delta cube, and this is delta power of n. This thing all we should substitute, and we are getting. Now see the example 2. They are asking to find out that at x equal to 15. So x equal to 15 means, so here. So 15 is nearest to 10, no? So you are using from forward difference table. So x equal to 15 forward difference table. So p equal to x minus x naught by h. Okay. X value means where we can find out that 15. So next, so here the p value is 0.5. So now just now we discussed, no? So that forward, in the forward we are getting the p value is positive. So all that values you can substitute here. So and we are getting that value. This is the things. And in same way, see the next problem, example 3. Find U32 when U20, U25, U30. But U30, 32, no? So 32 means you can take that forward only. So we can find that backward. 32 is nearest to here. Okay. So we are taking that forward. Or you can take the backward also. So if you are taking the backward, we are getting p value is negative. But when you are taking to the forward, we can get that positive value. So this is okay. So p equal to x minus x naught by h. Then here we getting the value is 2.4. So all we can substitute in the exam in the formula. So in the examination, it's compulsory using the forward and backward. Okay. Next, Lagrange interpolation formula. So this is also very important, Lagrange interpolation formula. Let y equal f of x be a So this is the Lagrange interpolation formula. And see, compulsory the problems coming in the examination, Lagrange interpolation formula and Newton's forward and Newton's backward. Okay. So this is the Lagrange interpolation formula. So find the using the Lagrange interpolation formula, and they given some data. So this is become x naught and this is become y naught. So first we are right. What is the x naught, x1, x2, x3? X naught is 1, x1 is 3, x2 is 4, and x3 is 6. And y naught is 4, and y1 is 12. Okay. And y2 is 19, and y4 is 7. So he is asking to find y5. Y5 means that is x value. Okay. X minus x1, x minus x2, x minus 3, and x naught minus x1 into x naught minus x2, and x naught minus x3 into y naught plus. So x minus x naught. So observe here, in the first term we can, x naught term will be not there, but in the denominator every value we can subtraction from the x naught and into y naught plus. Now here there is no x1. ఉంచే బయటకు ఉంచే బయటకు ఉంచే బయటకు ఉంచే బయటకు ఉంచే. Now this is x minus x1, x minus x2, y naught. Now this is y naught, y1, y2, y3. Now let's see here. Now we can substitute that all the values here. So x we need to find out, no? So x we need to find, that is 5, 5, and x naught value, x1 value, all we can substitute here. Otherwise, we can do the one more method. No need to substitute that x values, but x values we can find out from after the getting the polynomial. So after getting the polynomial, we can get that value of the what they are asking. If we are getting the polynomial, so if they are asking to the any value, here they given asking to find out that, here they are asking to find out that pi value, no? So if they are asking to the any value, we can find out there. Even if it is find out the polynomial function, and it's we are getting to there. Okay. Next. Same. So when we can use that Lagrange interpolation formula means, if it is there is unequal interval will be there. If there is unequal interval will is there, and then we are getting that Lagrange interpolation formula, we can use that. See the second one. So find that the table of x, then find asking the value of the 2.7. So they given 2, and they given 2.5, and they given 3. So by using the Lagrange interpolation formula, see in the examination they won't ask to solve this problem by Newton's forward, Newton's backward, and a Lagrange interpolation formula. First, you should remember the things. So depending on the questions, you can find out that if it is unequal intervals, so we can use the forward and backward. Unequal intervals, we can use the Lagrange interpolation formula. If it is equal intervals will be there, and we are using the forward and backward. The depending on that given questions, we can assume how we can do it is using the forward, or you can using the backward. But in unequal, we can use that Lagrange interpolation formula. So same thing, this we can formula x minus x1 into x minus x2 by x naught minus x1 into x1 minus x2 into y naught plus x minus x naught into x minus x2 by x1 minus x naught. So just we can substitute there, and we are getting that. Now that important formula, Newton's dividend formula. Okay, this is called unequal intervals. Also, we can do that. Lagrange's and Newton's dividend difference we can use, but unequal intervals. So how we can now in the unequal intervals. So next, this is delta f of x. Okay. So how we can the bracket of x naught minus x1 means y1 minus y naught by x1 minus x0, x naught. Next, what is the value of the x1 comma x2 means y2 minus y1 by that x2 minus x1. And what is the x2 x3 means y3 minus y2 by x3 minus x2. Okay. So in the same way here also the bracket of x naught x1 x2 means the bracket of x1 comma x2 minus x naught minus x1 by x2 minus x naught. So this is the difference. So in the same way, this is the Newton's central difference formula. So backward, forward, there is different, but this is. Now, just these asking to find out. So construct that Newton's dividend difference table. So they're asking to find construct the Newton's dividend difference table. Okay. 1, 2, 4, 7, 12. So we are getting 22, 30, 82, 106, 216. Okay. So 22, 30, 82, 106. So first we are finding that how we can find. So here we are getting 30 minus 22 by 2 minus 1. That we are getting 80. So in the same way next 82 minus 30 by 4 comma 2. So that's we are getting that 26. And next 106 minus 82 by 7 minus 4. So that's we are getting 8. Next 216 minus 106 by 12 minus 7. Then we are getting 27. Next, second, see listen, 26 minus 8 by this we can leave it the 2 ma. That we are getting 4 minus 1. Okay, next 8 minus 26. So this is 8 no. So 7 minus 2. And is anybody is there student? Is nobody is there. Next 27 minus 8 by 12 minus 4. So this we can find out that value. Next to see the next difference. Here see. Minus 36 minus 6. So now we can leave it the two elements 7 comma 1. Next 1.75 minus of the 3.6. Then we are getting again we leave the two limits. That is become 12 minus 2. And finally we are getting that 11. So this is central difference table. So how we can construct the central difference table? This is important. See in the short answers, in the examination, they will ask construct the central differentiation table means. So like this, we can find out that. You can see ma. Unfortunately, there is no students. If asking the question also, they won't reply. Okay. Next, trapezoidal rule. So what is the trapezoidal rule means? Just you should remember the formula. H by 2 first term plus last term plus 2 into the remaining terms. So that is called trapezoidal rules. And next Simpson 1 by third rule. So Simpson 1 by third rule. H by 3 into first term plus last term plus 4 into odd terms plus 2 into even terms. Okay. And next Simpson 3 by 8 rule. Simpson 3 by 8 rule, that is 3h by 8 y naught plus yn plus 2 into 3 multiple. 2 into 3 multiple means y3, y6, y9 plus 3 into remaining terms. What is the remaining terms will be there? Y2, y4, y5, y7, y8, y10 and y11 plus so on. Okay. So here that important you should remember that formulas. What is the trapezoidal rule, and what is the Simpson 1/3 rule, and what is the Simpson 3/8 rule. So this is are the important, and we can so see the first problem. So using the trapezoidal rule, Simpson rules, and we need to find that and use your rules and use the find the Ramberg integration also. So first H value 3 for trapezoidal rule, H value for 5 is Simpson 1/3 rule, and H equal 9 is the Simpson 3/8 rule. Okay. If n is not mentioned, then we can take n equal to 6. The default we can take that. If they are mentioned, there is no need. If they are not mentioned, we can take that n equal to 6, whatever may be. Now for trapezoidal rule. So the first formula is the trapezoidal rule. H equal to what is that? H equal to b minus a by n. So that is 1 minus 0 by 3, that is equal to 1 by 3. Now they're giving the function f of x equal to x by x cube by 1 by 2. So 0 comma 1, we can slip it. Say first 0. Next add 1 by 3. That is 0 plus 1 by 3. That is 1 by 3. Next 1 by 3 plus 1 by 3. That we are getting 2 by 3. Okay. And next 2 by 3 plus 1 by 3. That is become 3 by 3, that equal to 1. So we can stop here. So 0 to 1. So in this interval only we can find out, no? So that's we are getting 0 to 1. Now that integration of f of x into what is the trapezoidal rule? First term plus last term. So first term plus last term and plus 2 into remaining terms. So h value is 1 by 3. 1 by 3 by 2. The first term plus last term is 0 plus 0.769 plus 2 into remaining term 0.00277 and 0.0542. This is the thing. Okay. Next, Simpson 1/3 rule. So what is the Simpson 1/3 rule means? N equal to 5 and h equal to b minus a by n. That is 1 minus 0 by 5, that equal to 1 by 5. And x value, so 1 by 5, no? So first we are starting with 0 and adding the 1 by 5, that is become 1 by 5. Next 1 by 5 plus 1 by 5, that is 2 by 5. And 2 by 5 plus 1 by 5, 3 by 5. And 3 by 5 plus 1 by 5, 4 by 5. And finally 4 by 5, 5 equal to 1. So we can observe in 0 to 1 only. So you can take that 0 to 1 only, then we are getting. Now Simpson 1/3. What is a Simpson 1/3 means? H by 3 the first term plus last term and 2 into even terms and 4 into odd terms. So 2 into even terms. So this is 2 into even terms and plus 4 into odd terms. This is. So that is 1 by 3, 0.0769 plus 4 into this we can get. Now come to Simpson 3/8. So 3/8 means then we are getting 1 by 1 minus 0 by 9 and that we are getting 1 by 9. So 0, 1 by 9, 2 by 9, 3 by 9, 4 by 9, 5 by 9, 6 by 9. So how we are getting this value means, see that important information see there. Okay. So this is, here we can substitute. So in the examination, you can use the calcium. Y of 0 means just in place of x, we can substitute 0. So that's we can get 0 by 0 plus 12. That is nothing to what is that 0. Next, x equal 1 by 3. That we can write 1 by 3 by 1 by 27 plus 12. So like that, we can get the y values. Okay. And we can use the calculator, scientific calculator. In the examination also, you can use the scientific calculator and then we are getting that. Okay. Now this is the Simpson 3/8. See next. So evaluate, see that evaluate 0 to 6 1 by 1 plus x square into dx using trapezoidal Simpson 1 by third rule, trapezoidal Simpson 1 by third rule, and Simpson 3 by 8 rules. Okay, that 0 to 6, they're already they given h value is 1. So 0, 1, 2, 3, 4, 5, 6. So corresponding values, the y values, you can substitute in here. So here that f of x equal to 1 by 1 plus x square. Na? So 1 by 1 plus x square, and we are getting these values. Now trapezoidal rules. Trapezoidal rule. So what is a trapezoidal rule means? So I equal to h by 2, first term plus last term, plus 2 into even terms. And Simpson 1 by third, h by 3, first term plus last term, plus 2 in 4 into odd terms, plus 2 into even terms. So this is the things. And next, Simpson 3 by 8 rule and 3h by 8, first term plus last term, first term plus last term, and plus 2 into y3. Uh, that means 2 into 3 table. So 2 into 3 tables means y3, y6, y9. But y6 is the last. So already we write in here. So y9 is not there. So we can start from only 2y3 and plus 3 into y1 plus y2 plus y4 plus y5. So here we are getting like this Simpson 3 by 8 rule. Okay. So here this is the Nana. Okay. So this is the question. So here the next method, Rangakutta fourth order method. Okay. So that is dy by dx f of x comma y, and that y1 equal to y naught plus 1 by 6 k1 plus k4 plus 2 into k2 plus k3. So k1 equal to h into f of x naught comma y naught, and k2 equal to h into f of x naught plus h by 2 y naught plus y2. SEMA in the examination, the compulsory question for the long answer, Rangakutta fourth order method. So K1 equal to h into f of x naught comma y naught, and K2 is h into f of x naught plus h by 2 and y naught plus K1 by 2. Then y2 is become similarly y1 into 1 by 6 into K1 plus K4, and again we need to find out that all the values. So this is important for the examination. Okay, let's see problems on this base. So using Rangakutta fourth order, this is a Rangakutta fourth order. So solve Rangakutta fourth order method. Uh, solve the dy by dx equal to y minus x, where the initial condition they are giving that y of 0 equal to 0, and they're asking that x at x equal to 0.1. Okay. So dy by dx equal to y minus x. So that K1 equal to H into f of x naught minus y naught. So H into x naught minus y naught means that is y naught minus x naught. That is 0.1 into 2 minus 0. Then we are getting that 0.2. Okay. And next K2. K2 is H into f of x naught plus h by 2 comma y naught plus K1 by 2. X naught plus h by 2 means that is f of 0.0.1 by 2, that is f of 0.05, and K1 is 2 plus 0.2 by 2, that is we can getting 2.1. So that is 0.1 into 2.1 minus 0.5, that is we are getting K2, and K3 is h into f of x naught plus h by 2 comma y naught plus k by 2, y naught plus k2 by 2, then 0.1 f of 0.0. So this is Rangakutta method. RK method also we can say that fourth order, RK method of the fourth order. And here the one more problem is there. Dy by dx equal to x plus y square. Then initially they given y of 0 equal to 0. And where we can find out that 0.2. So y of 0 is 0. That is y of x not equal to y naught. So h equal to 0.1. X1 0.1, x2 0.2. So we need to find the y2. Since x2 is 0.2, no? So first we are finding the y1. So y1 equal to y naught plus 1 by 6 into k1 plus k4 plus 2 into k2 plus k3. So k1 into h into f of x naught comma y naught, that is 0.1 into f of 0 comma 0, that is become 0, and k2. So similarly we can find that k2 and 0.005, and k3 0.005, and k4 0.0103. Then we can find the y1. Just we need got y1 only, but we need the y2. Y2 means y1 plus 1 by 6 into k1 plus k4 into 2 into k2 plus k3. Then k1 we can find out this is 0.01, and k2 is 0.0153, and k3 0.015. It's very easy. Just we are using the formulas and we are substituting in that here. Okay. So this is K3, K4. Then after that, we are getting the Y2. So this is K3, K4. Okay, na? So in the examination, that RK method is a very important ma. So solve that using that RK method. Fourth order, that is a very important in the examination. Okay. RK method, fourth order, that is very important. And next to here, the one more topic will be there. uh, curve fitting. So curve fitting is also very important. That is least square. In the fourth unit, you have that the topic is in the fourth unit. The fourth unit, we are getting the least square and curve fitting. So how we can do the curve fitting? This is also very important in that in your textbook. It is the fourth unit, unit. Okay. So find the least square approximation of the first degree polynomial in the from the following table. So x values, they are giving x equal 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. So for the hyperbolic function, exponential function and hyperbolic function, then the normal equations of this is the straight line. So first degree, second degree and exponential function and power functions. So this is first degree polynomial that y equal to ax plus b. And then the normal equations are become y equal to summation of ax plus b and summation of y equal to, then we are getting summation a will be constant outside and a into summation of x plus n into b. So if you are multiply with both side x, that is summation of xy equal to summation of ax square plus summation of b into x. Here also we need the calcium. So this is x and y, xy and x square we need. So x values they are given, no? So x values they are given, and this is the y values, and their multiplication is that is xy and x square. 0 0.1 into xy 8.4. Like this we are getting xy, xy, xy. Okay. And final x square 0 0.1 whole square, 0 0.2 whole square, 0 0.3 whole square, and 0 0.4 whole square, and 0 0.5 whole square. So that's we are getting this thing. Okay. And we are getting summation of x and summation of y and summation of xy and summation of the x square. So this is summation of y is a into summation of x into nb. So all the values we can substitute in that equations in the normal equations, and we are getting this one. Okay, summation of xy is a into summation of x square plus a into summation of the okay, summation of xy and summation of the yx. Just wait, we'll go. This is. So we can use solve these two equations. So if you are solving these two equations, so we are getting a and b. So that a and b we can substitute in that ax plus b. So we have getting that a comma b, no? So a comma b in substitute in that linear equation that y equal to ax plus b. So this is the thing. Uh, and find the least square approximate second and degree polynomial from the following table. And second degree polynomial equation is that y equal to ax square plus bx plus c. And the normal equations are we are getting like this. So first we are multiplication with x, and next multiplication with x again we are getting x square by ax power of 4 bx cube and cx square. Okay. And the next x into y, x square, xy, x cube, x square y into x power of 4. Okay. And x, y and x square, x into y, x cube. And all summations we should find out. And All the values you can substitute in the normal equations. So equation 1 and equation 2 and equation 3. So if we are solving these three equations and we are getting a comma b comma c. So a comma b comma c, that we should substitute in that equation 1. So that y equal to ax square plus bx plus c. So in this. So this is the second degree equations and first degree linear equation, how we can solve that. So next we have that exponential function. Exponential function, that y equal to a into e power of bx. So apply the log is bound side. So log y equal to log of a into e power of bx. So that is log a. So log e power of bx. So that we can write bx into log e base e. So put log y equal to log small y equal to y. From here we can get it log b. Ln equal to capital Y. And ln A equal to capital A and ln B equal to B. Then small x equal to capital X. So just we are changing, that is in that first degree equation. So y equal to a plus bx. So that's we can write summation of y equal to summation of a plus summation of b into x, and summation of y, if you are multiply with n a plus b into n, summation of xy equal to a into summation of x and b into summation of x square. When we are multiply with x, then we are getting this one. Okay. Here summation of a means how many times we are adding, means n times, no, that we are getting n a. Okay. So now let's see. X, y and the small x equal to capital X, no, then we are getting the same thing. But the capital Y equal to ln y. So y equal to log of 4.0077 and we are getting 1.4054. And next to the capital X square. Capital X square means 4, 16, 36, 64, 100. And capital X into Y equal to this is. X square into X into Y. So all we are getting that. So we can substitute in that normal equations. Summation of y equal to NA plus B into summation of X and summation of XY. So all the values we can substitute here. So we need to find the A and B value. So after substitute that A and B values, so that is capital A equal to 0.4054 and the capital B equal to 0.5. But capital A equal to ln A, no, then A equal to become e power of A. That become e power of 0.4054 and b equal to small b and capital B equal to 0.5. So this is the thing.